right, if you are joining me, that means you are needing some intervention with the graphing part of 3A. So that's what we're going to be doing today. So you'll notice number 17, that is in what we call standard form, okay? So that means it doesn't quite just give me the vertex right out of the problem. I've got to do a little math to find it. So the main formula that we need to know is that x equals negative b over 2a. Okay, so when I do that, I need to know what A and B are, really. So A is going to be the number in the front, so that's just 1. B is going to be the second number, which is negative 4. Okay, so x equals negative b over 2a, so a negative 4 over 2 times 1. Simplify that. That gives me a positive 4 over 2, which is just 2. Okay, so that's the x value of my vertex, but I need to find the y value. Well, if I have an x value and I have a problem, I can just go plug in that 2 everywhere where there's an x. So I'll just plug in 2 squared minus 4 times 2 plus 4. I take my calculator, and where did that go? And I plug that in. Some of these you can do mentally, but I would recommend using a calculator just so we don't screw it up. And we end up getting 0 on that one, okay? So the vertex is just going to be 2, 0, which will be right here, okay? We also know that our line of symmetry, just that invisible line where this quadratic is going to reflect, goes through that point 2, okay? You don't have to draw that. It's optional, but if you just want to be able to see it, that it's there, I recommend drawing it, okay? And then we build our table, because once we have a vertex, we build our table around that vertex. So I need 2 numbers left of 2 and right of 2. So I've got 1 and 0, 3 and 4, and then I just go plug those numbers in, just like how I plugged in the 2. So I'll go plug in 0 first. So we got 0 squared minus 4 times 0 plus 4, which is just going to be 4, which means that 4 is also going to be 4. And then we go and we plug in 1. So we got 1 squared minus 4 times 1 plus 4. And that gives me 1, which means 3 is also going to be 1. Because again, this is symmetrical. So 0, 4 is right here. 1, 1, 3, 1, 4, 4. And there is my quadratic. So the hardest part is just knowing that. Using this formula, just like the quadratic formula, it just doesn't have that big radical. Okay, and then plugging that in to find the vertex, and then just building your table. Okay, we know that this quadratic is going to go left forever, right forever. So that's negative infinity, positive infinity. That's how all the domains are for these. Range bottom to top. So the y value where this starts at is 0, and it goes up forever to infinity. Limits, we just copy the domain. So negative infinity, positive infinity are our x's. And then we look. We know that the y's are always going to match on these because they're symmetrical. So is this going up forever or down forever? Obviously up forever. So we put infinity there. Okay, max or min, does this have the top of a mountain or the bottom of a valley? Obviously this is a valley. That vertex point is 2, 0. So I'll just call that a minimum. There will be no max. And then we've got our increasing, decreasing. This is probably the most missed part, okay? One reason I really like to draw in that line of symmetry and then just label what number that goes through, it's going through the 2, because that's the number that needs to be included in this interval. So if I look, if this thing was a roller coaster from left to right, it'd be going down from negative infinity, because that's left forever. Negative infinity to 2, it's decreasing. Sorry about that bell. Negative infinity to 2, it is decreasing. And then if we look at the roller coaster and trace it when it goes upward from that 2 to positive infinity, we are increasing. Okay. And then we just look for our x and y intercepts. These actually work out pretty easy. They're just in my table. And I can look at my graph too. My x-intercept is actually just that vertex, and my y-intercept is 0, 4. And that's it. Okay? Then we move on to the vertex form one. These are a lot easier, and we've actually already done these. We did these in Unit 1. Okay? okay? We know that the vertex is just negative hk, meaning change the sign of h and k. That's the vertex. So here, if I look, it looks like h is -1, but that means it's actually +1. And then k is also +1, okay? And now we build our table around that. So this one's actually a lot easier. So 1, 1 goes in the middle. Two numbers to the left of 1 are going to be 0, -1. To the right, 2 and 3. And now we just plug them in. So I'll plug in that -1. So I got negative parenthesis, -1 minus 1 squared plus 1. We get -3. And that would be the same for 3. Go back, change it to a 0. And I get 0. Okay, so I've got my points that I just want to graph. So -1, -3, 0, 0, 1, 1, 2, 0, 3, -3, and there is my quadratic going down, okay? I would recommend, again, putting in that line of symmetry. You don't have to, but it helps, and then writing the number it goes through, which again is going to just be 1. And we know left forever, right forever is always the domain. -infinity to +infinity. Range on this one is bottom to top. So it's starting coming down forever, -infinity. It's ending at 1, the y value of 1. X is on the limits. We just copy down the domain. Okay. -infinity, +infinity. And then my y's, we know they're always going to match, and they're both going down forever. Max or a min is the top of a mountain or the bottom of a valley. Obviously, it's the top of a mountain, it looks like, so that's a max, not a min. Increasing, decreasing, so we trace this thing as if it were a roller coaster. From -infinity to that line of symmetry at 1, this thing is increasing. And then from 1 to infinity, it's decreasing. X and Y intercepts, again, got pretty lucky with this. I can pull them from my table. X-intercept, it looks like I actually have 2. 0, 0, and 2, 0. And then y-intercept is also going to be 0, 0. And that is it. Okay, so that is the practice. Go ahead and do your own practice, check your answers, and then you'll be ready for the requiz. Thanks, guys.